All right, time to start chapter 9. So this chapter is going to be all about just reactions and a lot of different criteria about reactions. So we're going to get more into, I guess, kind of the nitty-gritty of chemistry and how things happen. The first thing we're going to do, this first section, is actually just a quick rundown of types of reactions. Yes, I can test you on this, but it's mostly that I want you to be able to recognize the types of reactions when you see them. Because you'll see certain kinds of reactions come up over and over and over and over again, and being able to recognize them is helpful in predicting them. So the first type, we're going to talk about 5 types pretty quickly here. So the first one is the combination reaction, where you take 2 or even more things and you put them together. So here's my general, in each of these slides I'm going to show you the general reaction and then a bunch of examples of it. Where you take something and add it to something else and get one product, right? So you're combining 2 things, combination reaction. Combining it into one thing. Now this could either be more than 2 things. This could be 3 things or 4 things. 2 is really the most common for reasons that we'll actually talk about. It could be 2 elements, or 2 like single atoms. It could be 2, molecular elements. It could be an element, a molecule. It could be 2 compounds. It could be 2 of anything. It doesn't matter what they are. It's 2 things become one thing. Now, no, I'm not expecting you to be able to predict. I'd expect you to be able to predict this and this, but not really anything else. I wouldn't expect you to be able to predict these other things. But just so you can see them when you recognize them when you see them. The next type is the opposite. It's a decomposition. We're breaking it down. So we're taking one thing and breaking it into 2 or more things. So copper, copper 2 oxide becomes copper and oxygen, and breaking this down. So anytime you break one thing into 2 things, so this is why AB goes to A and B. Okay, the next type is called a single replacement reaction. So this is a little more complicated. But what we have is, we have the X, and it's paired up with B on the reactant side, and then on the product side, A has replaced B and kicked B out. So A and B switch places. So you have one thing, and then you have A replacing B. So that's why it's single replacement. So here's an example. We have iron and then copper sulfate. Iron replaces the copper in the sulfate, and then copper just becomes copper metal. Magnesium and nickel. Oh, actually, I should finish that out. So, actually, this is a good opportunity to predict this. I don't know why I don't have this thing finished off here. But it should be magnesium nitrate plus nickel would be what we have, right? Magnesium is replacing the nickel. Here, this one's a little weird. The pH3 is actually replacing the CO. A little strange, but it's just one thing replacing another thing, so single replacement. The next type is something called double replacement, where you have 2, you have X and Y, and they swap. Now this is most commonly going to be, we talked about precipitation reactions. Precipitation reactions are double replacement. So we have silver nitrate and the sodium chloride, and because we make the precipitate silver chloride, we swap silver and sodium, and they switch places. So silver goes with the chlorine, and sodium goes with the nitrate. Ki. The potassium goes with the nitrate, and the lead goes with the iodide. There we go. Although this doesn't appear to be balanced. I should balance this. There we go. The last type is a combustion reaction. Now this is a little, I don't have a nice little A-B list for this one. This is a reaction between a substance and oxygen that always proceeds with the creation of heat and light. Okay, so we're only really going to talk about the combustion of hydrocarbons. Hydrocarbons are things with hydrogen and carbon in them, so H and C. So if you had like C3H8 and react it with O2, you always get the same 2 products. So this is the one type of reaction I am definitely going to expect you to be able to write. Because with hydrocarbons, you always get exactly the same 2 products. All of the carbon goes with oxygen to make CO2, and all of the hydrogen goes with oxygen to make water. And then I can balance it as I need to. 3, 4, whoops. And then I have 4, 6, 10, so 5. So there we go. And so here's another one that I've done, but there it is. I mean, it's always going to produce, hydrocarbons always produce CO2 and H2O. You might have oxygen. You might have oxygen in there. So if you had C2H6O plus O2, you still get CO2 and water and would just balance it appropriately. It doesn't matter if there's an extra oxygen in there. But you can also get combustion between oxygen and other elements like sulfur and magnesium and things like this. It's just a combination of that element with oxygen. I'm not going to make you predict these. But hydrocarbon combustions, definitely. I might make you write those out. Okay, all I want you to do, this is very simple. I want you to just take a minute. I want you to predict, just classify what type of reaction it is. Okay, so the first one, you see the copper and the aluminum is switching places. The aluminum is taking the place of the copper. So this is a single replacement. Right? Now the second one, this is breaking into one thing is breaking into two things. That makes it a decomposition. This one, we have the silver and the potassium switching places, or rather you could say the nitrate and the sulfate are switching places, but that makes it a double replacement. And then, here we have two things becoming one, so that's a combination. Then we have oxygen reacting with a hydrocarbon to make CO2 and water, that must be combustion. And that's really all there is for that part. Just those 5, just be able to recognize those 5 types of reactions.